as I love to show, is there's not just 16. There's actually thousands of these chemicals. Thousands. We've picked 16. 1976, the smart people in the world picked those 16 and said, this is what we're going to go with. Then we get into the alkylated pHs. This is more of a specialty analysis, where we measure alkylated pHs in the samples as well. What do we do with alkylated pHs? Well, first of all, we actually don't measure all of them. We just measure them as groups, and I'm going to talk about that in a second. What are alkylated pHs? So this is naphthalene. It's a 2-ring PAH right here. If we can alkylate it. So we're going to put a carbon group on it, which is a methyl. And we can put the methyl on this spot, or we can put the methyl on that spot. And that's 1-methyl naphthalene, and that's 2-methyl naphthalene. If I put it on this spot, it's actually the same as that one. I could just flip my ring over. Everybody remember their stereochemistry? I could put it on this one, but I could just flip that over, and that's that one. There's actually only 2 PAHs that are alkyl 1-methyl naphthalene, 1 and 2-methyl naphthalene. So what I'm showing here is there's only 1 naphthalene. There's 2 C1 naphthalene. So the C represents the methyl group. There's only 1 of them. That's what the 1 means. And it can go into 2 different positions. So there's 2. All right, now we're getting to the fun part. C2 naphthalene is where I can put 2 alkyl groups on it. So that can be 2 methyl groups, this one and this one. So see, this is 1,2 dimethyl naphthalene. Or I could put an ethyl group, which is 2 carbons as well, in one spot, right? So I can put that ethyl group there or there, so there's 2 of them. I can put these methyls here and here. I can put it here and here. I can put it here and here. I can put it here, here, here and here, here and here. Oh, there's 12 of those. So there's actually 12 C2 naphthalenes. But we quantify them all as 1, as I'm going to show that. C3 naphthalenes, guess what? Gets more complex. We can have a methyl, we can have an ethyl, or we can have a propyl. And all of those could be made. So there's actually, and someone's already done the math, there's a publication I'll show in just a second. There's 32 different congeners of the C3 naphthalene. So naphthalene, the one compound we measure that has 2 benzene rings together, if you take its family, there's actually 157 different congeners present, okay? So we're usually representing naphthalene with 1 measurement when there's actually 157 different ones. And the alkylated pH analysis that you'll get done is going to report 1, 2, 3, 4, 5 different numbers. So we combine all of these into 1 number, all of those into 1 number, those into 1 number, those into 1 number, and that by itself. And that's alkylated pHs. And, sorry, this is a GC chromatogram of just the naphthalenes. I forgot to mention this. This is my other thing that I love to talk about, where we're actually going in and we're separating all the different naphthalene compounds that are present in the sample. So all these little blips here, every single one of these little bumps is one of those isomers or one of those congeners of naphthalene that are present. And so you can imagine the environmental forensics that's capable with something like this as opposed to just the 16 or even the alkylated. We can get pretty sophisticated in our pattern recognition. And that's where the world's going. Probably needs another 10, 15 years, but this is when we can handle this type of data, process this data, and look for similarities, that's where it's going to end up. And to give you an idea of how crude or it sounds rude, how good we can do this now, but this is sort of, this is chromatogram, I call these humpograms. This is how we integrate alkylated pHs, where the C1 naphthalene is those 2 compounds, so we just draw a line underneath the 2 of them, and there's total together. The C2 naphthalenes is this humpogram here, so we just integrate from point A to point B and say all of that is the C2 naphthalene. C3s, where there's 32 of them, we just integrate. So these are sort of these big humpagram, histogram plots that we do to be able to summarize the naphthalenes without going into the detail of measuring each individual compound in a GC-GC. So this is the one-dimensional GC chromatograms. If you're doing alkylated pH analysis and you need it, this is the data that you'll be using. This is what it looks like before you get the little number and just take that number and put it into your histogram plot. And that's what the C4s look like. So it gets pretty messy. You can see here, like, you're integrating this and then you're stopping at this. And the lab knows that they need to stop because this is a new pH that's the next eluting pHs that are coming out. And then, so this is Wesley. This is the young yeah, I don't know how young he is. He works at CoGrad at University of Manitoba. He's the one that came up with the algorithm to calculate the number of potential isomers of pHs. So look that paper up if you really want to read about it. But what we use alkylated pHs for, and whenever you want to know the sources, I highly recommend you do alkylated pHs. So maybe do routine pHs, figure out what samples you want to do, and then have them run for alkylated pHs if you want to sort of screen your data. Because you can see a lot more with alkylated pHs than you can with routine. And I'm kind of showing you where I like to go in routine environmental investigations. I like to get to this point. You can do a little bit with just the 16, which we're going to talk about, but if you get the alkylated, it's so simple, it's crazy. So highly recommend that. Again, AGAT does this out of their Edmonton lab and can provide you these. There's multiple different packages available. I've seen up to 70 different things being reported in alkylated pHs. Routine is about 37. There's a 55 pH pattern, depending on what labs you use down in the States, which is where I do most of my work. There's a whole bunch of different alkylated pH patterns. Anyway, if you do get alkylated pHs, you draw these histogram plots. It's almost easy to tell where the sources are. And usually we're trying to tell pyrogenic from petrogenic. Say we're measuring a petroleum spill. We're looking for these petrogenic humps, which are these humpograms that happen here. You can see that every group of PAHs has a hump. And that's a petroleum-derived PAH. Okay? Those are all coming from petroleum. This is a heavy fuel oil. Whereas if they were pyrogenically formed, they were combusted, burned, we always get these scree plots. So you can see the parent pH is always the biggest. Parent pH is always the biggest. Parent pH is always the biggest. And that's a very easy distinguishing trait between petrogenic and pyrogenic, and very easy to, petrogenic, pyrogenic. Very easy way to tell them apart quite quickly. And just to reiterate this point about number of pHs, this is the number of PAHs that is in each of these groups. So there's 157 things being represented by this cluster. There's 576 things in this. There's 576 of these and 308 of those in that one. 299 in that one. 576, 308 in that one. So that just gives you an idea of the amount of compounds that you're measuring as part of your alkylated pHs.